Everyone, I'm Snehal Purani, lecturer at Sri KG Polytechnic, Bharuch. So we are starting our new journey with solar energy estimation. So this is our first lecture, and the topic is solar energy basics. So today we are going to discuss on some points like importance of solar power generation and its utilization, its historical background, basic working of solar photovoltaics, important information regarding solar power generation, basic terms related to solar cells, solar power plant components, advantages and disadvantages with solar power system. So here it is. Importance of solar power generation, its utilization. As we all know, sun is the source of energy and it is available in abundance and free in the nature. It is a clean form of energy, hence it is environment friendly and no fossil fuel is required for the power generation using solar. Its utilization is possible with the help of inverter, or it can be directly utilized or stored in the batteries, or we can directly run the DC load connected with the systems. It can be installed at the load centers, hence transmission and distribution losses can be reduced. This is the important point for the transmission and distribution engineers who are dealing with the power losses and load profile and load flow analysis and its efficiency calculations. So, with the historical background, this is the basic info of the Sir Alexander Edmund Becquerel, who has invented the Becquerel effect, and the French physicist who studied this solar spectrum, magnetism, and electricity and its optics. He is credited with the discovery of the photovoltaic effect, the operating principle of the solar cell in 1839. At the age of 19, experimenting in his father's laboratory, Becquerel created the world's first photovoltaic cell. The photovoltaic effect, which was discovered by the Edmund Becquerel, is the photovoltaic effect is the generation of a voltage and electric current in a material upon exposure to light. It is a physical and chemical phenomenon. When any material is exposed to a sunlight, uh, the free charge carriers are generated and they are passing from cathode anode to cathode like this, and we can connect the external load, so we can use this solar energy to utilize the same in the form of electrical energy. It is also known as the Becquerel effect. This is the experimentation done with the metal electrodes and electrolyte. So this shows when it conducts with the discovered that the conductance means the resistance is decreasing with the amount of sunlight imparted on the flat surface of any metal conductors. Then, utilizing this, Charles Fritz, the American inventor, has invented the first selenium cell in 1883. It is the world first solar rooftop array using selenium semiconducting material was installed in 1884 on a New York City rooftop. Fritz coated the semiconductor material selenium with an extremely thin layer of gold, resulting in the conversion of electrical efficiency is about 1% owing to the properties of selenium, which is combination with the material's high cost prevented the use of such cells for energy supply. As the efficiency was very small and gold is an expensive metal, it will cost us in huge amount for generating or producing very small amount of electrical energy with the help of this kind of solar cells. As and when the in research laboratories have studied a lot, and some semiconducting materials are developed with the help of these material innovation in material science, and the research laboratories are continuously working on the improvement in efficiency. Today we are having a very good amount of efficient solar cells with us. This we will see in the upcoming slides. So this is the basic working of solar photovoltaics. So solar photovoltaic works with the uh, As the name suggests, the solar photovoltaics works on the solar energy. When solar energy is incidented on any material, it produces the photovoltaic effect. So the conversion is possible with the help of the most abundant element available on the earth, that is sand. Sand is converted into 99.999% pure silicon crystal to use in solar panel. The purification process was done like this: sand with mixed with the carbon, and it is heated on the temperature of 200 degrees centigrade. It will produce raw silicon, which is 98% pure. Raw silicon is now converted into a gaseous silicon and then mixed with the hydrogen and get highly purified polycrystalline silicon. This is the way how polycrystalline silicon power panels or solar panels are converted. It is then converted into very thin plates called silicon wafers. This silicon wafers is the heart of solar cell. Means this is a simple piece of a photovoltaic cell. If we analyze the structure, we can see the bonded atoms. Same things happens with the silicon atoms, which are connected with each other with the help of covalent bonds. If we are injecting the phosphorus having 5 electrons in it, it is the p-type uh, impurity into it will create one free electron which is free to move in the structure. This electron, when gets the sufficient amount of energy, this will move freely in the structure, but this free electron will not converge or not produce any electricity, as the movement of this free electron is very random in the nature. So if we want to result any current through the load, we have to provide a driving force to it, and the easy and the most practical ways to produce the driving force is the p-n junction diode. So similar to this n-type doping, if we inject p-type boron with 3 valence electrons into pure silicon atom, there will be one hole for each atom. This is called p-type doping. This kind of doped material, N and P type layers connected together, forms p-n junction diode, and the region near P and N, it fills the p-type electrons and holes are recombined, and this forms the depletion layer. This depletion region is the region of p-n junction where there are no free electrons as well as no free holes. So no conduction takes place during in this depletion region. Due to the migration, the n-type boundary is slightly positively charged and the p-type boundary becomes negatively charged. An electric field is formed between these charges across the depletion region. This electric field produces the necessary driving force. Light strikes on the N region of the PV cell. It penetrates and reaches up to the depletion region. This photon energy is sufficient to generate electron-hole pair in the depletion region. The electric field across the depletion region drives the electrons and holes out of the depletion region. So they becomes free from the depletion region. Due to this, the concentration of the electrons in the N region and concentration of holes in the P region becomes so high that the potential difference develops between them. As soon as we connect any load across it, electrons will start flowing through that load. These electrons will recombine with the holes in the p region after completing the path. This way, PV cell will continue gives us the DC current. The practical PV cell top layer N is very thin and heavily doped, whereas P layer is thick and lightly doped and at the bottom of the surface. This kind of connection is this kind of adjustment is provided to increase the performance of the cell. How? Let's find out. The thickness of the depletion region is much higher in the P region. This means that due to the light striking the depletion region, an electron holes are generated in the wider area, which results higher amount of current by the PV cell. Due to thin top layer, more light energy can reach to the depletion region. This is why the N layer is light, heavily doped, and it is very thin, and it is placed on the upper portion. Upon testing in the laboratory, newly manufacturing solar cell displays the efficiency of nearly 20%, as they can convert 20% of energy from the sunlight into the electric current. However, hours of operation, that efficiency will reduce to 18%. It is not a big issue if 10% of the total power drop of installed capacity, still that will equivalent to 30 or many nuclear power plant. If solar power plant operates on 24 hours basis, which is it is not possible because the sun is available for 12 hours or more to more 10 to 15 hours in a range. Losses in conversion and also electrical losses in wires, etc., will further reduces the efficiency. See, this photovoltaic cells use photovoltaic effect. So in this, photon of a particular threshold frequency striking a material can cause an electron to gain a notch energy to free from their atomic orbits and move freely in that material. This is best achieved with semiconducting materials. So semiconductor property is such that it is the property between the metallic conductor and insulator which allows them to move easily electrons from atomic orbits to move freely among their atomic structure. The incoming solar light can be reflected, absorbed, and passed through type, means transparent. Only the absorbed amount of light can convert the photon energy into electricity. Means this absorbed energy is the useful term or the useful energy from the sun available to convert the solar energy into electrical energy. So to increase the efficiency of the cell, first of all, reduce the reflection of light. Actually, 30% of the light falling on solar cell gets reflected. Hence, before functioning, the maximum efficiency reduces to 70%. This is the way. The amount of solar radiation on the flat plate collector, it seems like it is reflected, it is absorbed, and it is a pass-through type, means transparent in nature. So to increase the amount of absorption, we are treating the surface with the help of this titanium dioxide, silicon monoxide, and the pure silicon at the down surface. Surface treatment can be done for the increasing absorption. And silicon is now covered with a layer of silicon monoxide to reduce the reflection of the wave by just 10%. From earlier, it is 30%. With the second layer of titanium dioxide, it reduces the reflection as low as 3%. So we can absorb 97% of the total energy that is incidenting on a flat surface. Texturing the surface, increasing the probability of absorption. Now we are going with the basic calculation. As we all know that energy of that photon is equivalent to Planck's constant and the frequency of the photon which is going to imparted on the flat plate collector. So E is equals to H into F. This H is the Planck constant and its value is 4.136 into 10 raised to minus 15 electron volts. Now, silicon will require the photon with the 1.1 electron volt to produce the photovoltaic effect. So 1.1 E is equals to 1.1 is equals to 4.136 into 10 raised to minus 15 into frequency of the photon. So with this, we are getting the frequency of the photon is equals to 2.66 into 10 raised to 14 hertz. So wavelength of this lambda is equals to C by F, where C is the velocity of light. It is 299732458 divided by 2.66 into 10 raised to 14 is equals to 1110 nanometer. So this is the wavelength of this silicon photon required to free the or to generate the electricity with the help of silicon material. With this, if this is the amount which is useful for producing the generation, that is 1110 nanometer. This is the wavelength and this is the spectral irradiation in watt per meter square per nanometer range. Out of which this 19% is the not suitable one, means the efficiency is further reduced by 19%. See, 4% of this total energy emitted by the sun in the form of ultraviolet radiation. So 44% is in visual light and 52% is in infrared region. With silicon, we can use up to 1110 nanometer. Means the higher value of the wavelength is not converted, means the total amount of 19% of energy is wasted till date. So light with higher energy does not release more electrons. It simply produces higher energy electrons. This can simply lose the extra energy in the form of heat and cannot free extra electrons. This loss is nearly 33% of sunlight energy being lost. Hence, 33% plus this 19%. This 19% total is 52% is wasted. Silicon forms these covalent bonds with neighboring atoms. So with the help of silicon, we are just getting the amount of efficiency is nearly 48%. This is the latest chart of module efficiency which is provided by the National Renewable Energy Laboratories, which with this we are getting 40.6%, and these are under the laboratory condition. Right now we are just checking it at the laboratory level. Some basic terminology is related to solar cell. It is a form of photovoltaic cell defined as a device whose electrical characteristics such as current, voltage or resistance vary with when it is exposed to sunlight. Individual solar cell devices are often the electrical building blocks of the photovoltaic modules. With the help of so many solar cells connected with each other, it produces the module, and so many modules connected in series parallel combination forms the array through which we are getting the available power as per our requirement. This structure of solar cell is like this. It is a thin layer of P and N type materials. This layer of cells, the connection through copper strips, which is the top portion is -1 and bottom portion is +1. So N and P layers are connected like this in series connection. We are connecting above it. We are using EVA sheets on the both the sides of cells, because EVA is the abbreviation of ethylene vinyl acetate to increase the amount of concentration. Glass cover is provided to avoid the physical damage and the increase the transparency, or we can cleanliness, so that more amount of sunlight is concentrated on the surface of this solar cell. Metallic plates for mounting over structure. Solar power plant components. We require to build a solar power plant. We require solar panels, its mounting structure made up of aluminum or steel, cables and connectors, inverters, protective switches, system earthing, protection against lightning strikes, solar meter and bidirectional meter sometimes, or charge controller. Batteries for standalone system, other miscellaneous items like screwdrivers, screw, P-clips, welding rod, etc. for the connection purpose. The advantages with the solar PV system is it is a clean and renewable energy resource. Once a solar panel is installed, solar energy can be produced free of charge. Solar energy will last forever, whereas it is estimated that the world's oil reserves will last only for 30 to 40 years. So we have to check for the alternatives. Solar energy causes no pollution. Solar energy makes absolutely no noise at all. On the other hand, the giant machines utilized for pumping oil are extremely noisy and therefore very impractical. Very little maintenance is needed to keep solar cells running. There are no moving parts in a solar cell, which makes it impossible to really damage them. In the long term, there can be a high return or investment due to the amount of free energy a solar panel can produce. It is estimated that the average household will see 50% of their energy coming in from solar panels. But the disadvantages with the solar PV system is it is really expensive. The initial cost is very high. This will result in a time lag of many years for saving on energy bills to match its initial investment. This means the payback period or return of investment period is very long as compared to its initial investment. Electricity generation depends entirely on a country's exposure to the sunlight. This could be limited by a country's climate. Solar power stations do not match the power output of similar sized conventional power stations. They can also be very expensive to build and require large space. Solar power is used to charge batteries so that the power device can be used at night. The batteries can often be charged and heavy, taking up space and needing to be replaced from time to time. So with this, we are concluding this session. The Samuel Langham Clemens has said that the man who does not read books has no advantage over the one who cannot read them. This is because this quote is to impart the importance of the education in for today's generation. Thank you. Thank you so much for listening.